Hello, Riles. For lesson number 3.5, let's talk about another definition, and we'll see if we can write it out again without symbols. Let's talk about what it means for the point P to be an inflection point. P is an inflection point. Let's say for the function f, if first thing that has to be true, again, if P is going to be an inflection point on f, then P has to be on f. So let's say that P's input is an element of the domain of f. Doesn't need to be an element of the domain of f prime or f double prime. That's very important. And there's only one way that one definition, one condition that can be satisfied. There's more than one way that this can happen, but what we're looking for is sign change. And f double prime, the second derivative, changes. Let's say the outputs from the second derivative, f double prime of x, changes sign over P's input. Okay, this is very important, and it is one of the most common mistakes that I see in this course, even all the way up to the final evaluation, is that to try to find an inflection point, students set the second derivative to be equal to 0. And the phrasing that I want you to consider and reflect on and internalize, I hope, is that a root of f double prime is not necessary or sufficient. Necessary means it would be required, that the only way that you can have an inflection point is having a root. Sufficient means it's good enough, meaning that if you find a root, then for sure you have an inflection point. Okay, these two conditions are usually separate, and you can find some examples by just doing your own search. Let's talk about being a mammal and being a cow. Here are cows, and here are mammals. You're going to notice that if you are a cow, it is necessary that you are a mammal. But being a mammal, well, it's necessary for being a cow. It's not sufficient. Just because you're a mammal doesn't mean you're a cow. Okay? Sufficiency. You can be sufficient but not necessary. Let's talk about integers and rational numbers. We'll see the same sort of relationship here. Here are the integers. Here are the rational numbers. If I tell you that a number is an integer, then that's sufficient for you to say that it's going to be that you're also going to be a rational number. But it's not necessary. There are rational numbers that aren't integers. Play around with the words. It's not definitions that I need you to use at all, and you don't need to mention this in your definition. This is our thought process over here. I think the best way to develop an understanding of these two facts is to hang on to my two favorite examples. We probably saw them in class or in our lesson. And those two examples are f of x equals x to the exponent 4 and g of x equals the cubed root of x. I like these examples because they are the simplest examples that I can think of where these conditions are true, but the conditions of roots sort of fall apart. I also like them because they're two functions that we should be able to sketch quickly. We know what a parent quartic looks like, and we know that we are expecting no inflection points. Let's keep that in mind when we look at the second derivative. We know what g of x looks like. We might have less experience with it, but we know what a parent cubic looks like. Visualizing this as an inverse of a parent cubic. There. We should be ready for an inflection point. Let's keep that in mind when we look at our second derivative. Okay. Label these. And it also shouldn't take us too long because the functions are relatively straightforward. First derivative, f prime of x is going to be 4x cubed. We could look at the fact that we have a critical number of 0 and our first derivative changes sign as we cross 0. Therefore, we have a turning point. See, the definition of an inflection point is closer to the definition of a turning point than a critical point. To have a turning point, you must have a change of sign of your first derivative. To have an inflection point, you must have a change of sign of your second derivative over an element of the domain of the original function. Notice that f double prime of x, it has a root when x equals 0. But why would I expect there to be an inflection point at x equals 0? So when I ask you to find inflection points, I do not want you setting f double prime of x equal to 0. It's not necessary for you to have an inflection point, and it's not sufficient. So don't do it. I want you to analyze the sign. I think you could just say here that there is no sign change to f double prime. Therefore, f has no inflection points. Let's look at g of x. G of x, maybe we write it with a rational exponent just for differentiation's sake. G prime of x is going to be 1/3 times x to the exponent -2/3. Let's go to g double prime of x is going to be the, sorry, take my time here. -2/9 times x to the exponent -5/3. And then I can rewrite this. Let me keep those labels there. I don't think there's any need to write nothing on the left-hand side here. Let's go -2 divided by 9 times the cubed root of x to the exponent 5. Oh, look, g double prime of x doesn't have any roots. Who cares, though? Having a root is not necessary for us to have an inflection point. So don't set g double prime of x equal to 0. It's unrelated to whether g has an inflection point or not. So don't do it. It will cause, it demonstrates a misunderstanding of the definition and will likely cause a loss of a mark, even if all of your final conclusions are correct. What we can do is we can look at this odd exponent and that odd exponent or odd nature of the exponent there and just observe that we're going to experience, you could say g double prime of x changes sign. You could prove this with a factor interval chart if you want, but I mean, there's just one factor that changes, right? It's a monomial. Changes sign over x equals 0. It'd be interesting to look at the sketch because notice that 0 is not an element of the second derivative's domain. 0 is not an element of the first derivative's domain. We also don't really care about that as long as it's an element of the original function's domain. Therefore, 0 comma g of 0, which we could evaluate to 0, is an inflection point. This is what we expected from our sketch. We can't always rely on our sketch, though, because we're going to need to use these facts to help us draw a sketch. So review these simple examples where you can see and you can predict what's going to happen, and review this definition and review this fact, because it's by the third time students make this mistake in a course, teachers tend to be unforgiving as far as mark assignment goes. Okay.